Hello, everyone. Can you hear me? Are there any questions before we get started? Okay. And you can see my screen. Okay. So for this first one, we have what is the probability of getting more heads than tails on 4 tosses of a fair coin? So I'll give you about 3 minutes to do that on your own. Maybe 2 minutes. Close, Brendan. Yeah, probability. Okay, getting some interesting answers. So I think I know what one of them is. 7 out of 24. I'm not sure how you got that. So let's start with the sample space. So our space is the set of all 4 coin tosses. And the size of that is 2 to the 4th, because each coin toss has 2 outcomes that are equally likely. Yep. And then so our event equals more heads than tails. And we can break this into 2 events. So events E1 and E2, where E1 equals 3 heads, and E2 equals 4 heads. So the number of E1 is equal to 4 choose 3, and the number of E2 is equal to 4 choose 4. 4 choose 3 is equal to 4, and 4 choose 4 is equal to 1. So the probability of E is equal to the number of E over number of the space, and that's equal to 4 plus 1 over 16, and that's equal to 5/16. Any questions on that? Okay. So I think this is in your homework problems. So if the Bisons have a 3 out of 5 probability of winning any given game against the Mustangs, what will be the average length of a best-of-5 series between these 2 teams? So the number of games played until one team has won 3 games. So we have to think about three things here. So let's say x equals the number of games. And what we're looking for is the expected value of x. And x can equal 3, 4, or 5. So I'll give you about 3 minutes to think about this, unless you've already done it.
Can I ask a question first?
Yes.
So I know there can only be 3, 4, or 5 games, but does that account for the Bisons winning and the Mustangs winning? Do you have to do
yes. Yeah. Okay. Yeah. That's a very good. That's a very good question. So this 3 case has to account for both the Mustangs winning and the Bisons winning.
So would you have an expected? So you do like the expected value, like what for probability of 3? You do it twice, once where the Bisons get 3 and once where the Mustangs get 3, and then you add that all together.
Correct. So for 3, right? So for the expected value of x, we're going to have 3 times the probability that x equals 3, right?
Yes.
Plus other stuff that I'll write later. This includes the case where the Bisons win the tournament and the case where the Mustangs win. So Bisons can win or Mustangs can win.
So for this problem, we want to use like Bernoulli trials?
Yeah.
So can you do like the Bernoulli trial of the Bisons winning plus the Bernoulli trial of the Mustangs winning?
Yes.
And then multiply that by 3?
Yes.
Okay.
And I'll finish out the expected value calculation. So we have 4 times the probability x equals 4 plus 5 times the probability x equals 5. So what we need to find is probability that x equals 3, probability that x equals 4, and probability that x equals 5. So I'll let you work a little bit more on that. Yeah, that looks right.
We have to simplify it, or like, can we just write down the
Yeah, they're
formula?
kind of nasty.
Yeah.
Yeah, so let's just get started with probability of x equals 3. So this is Mustang's win or Bison's win. And these are mutually exclusive events, so we can just use the straight sum rule without overlap. So what is this one? So the Bisons win 3 games at 3/5 probability, or they win, but the Mustangs won the tournament at 2/5 probability to the third. So it's either 3/5 to the third plus 2/5 to the third. And if you're curious, that's 175 over 625. How's that 625? Not reduced. Okay. So for probability of x equals 4, so when we're looking at probability of x equals 4, then either Bison's won 2 of the first 3 games and win the 4th, or Mustangs do the same thing, replacing Bisons here. So the Mustangs won 2 of the first 3 games and then go on to win the 4th. So there are 3 ways that the Bisons could have won the first 2 games. So choose 3, 2 times by 3/5. So the Bisons are winning 2 of the first 3 games, and the Mustangs lost 1/1. So we multiply by 2 over 5. And or the Mustangs won 2 of the first 3 games, so we have 3 ways from there, and we get 2 over 5 squared. I forgot one piece. Sorry. Let me erase this. So here we had the Bisons won the first 2 of the first 3 games. The Mustangs won 1 of them. And then finally, the Bisons won the 4th game. So this is times 3/5 again. Or the Mustangs won 2 of the first games. So we have choose 3, 2 ways times and then they won 2 of the first 3 games. So we have 2/5 squared times 3 over 5 because the Bisons won 1 of those games, times 2/5 because they won on the 4th game. And those 2 together apparently come out to 234 over 625. Why is it 3 choose 2 instead of 4 choose 3? Because we know that there okay, yeah, so why is this 3 choose 2 here instead of 4 choose 3? It's because so right here, we're looking at the Bisons win the tournament. So the way the tournament works, we know that the Bisons won here, the 4th game. And so that means that they didn't win the game in 3 games. They didn't win the tournament in 3 games. So we have to have 2 Bisons in these 3 slots here and 1 Mustang. Okay, yeah. Anyone else still confused on that? Okay. Yeah, the Bisons can't win 4 games in a row because they would have won the tournament at 3 games. And then finally for where P of X equals 5. So this means that the tournament lasts 5 games. So, so we have 5 blank slots. And let's just say for the Bisons, we know that they didn't win in the first 4 games. So there's 2 Bisons that we have to put into these first 4 games and 2 Mustangs. They have to go in here. So so we have, we're choosing 4 from 2 for the 2 slots that the Bisons are in. And that determines where the Mustang games are. And then we have 3/5 squared for the Bisons winning 2 games times by 2/5, 2/5 squared for the Mustangs winning their 2 games. And then for the case where the Bisons win, we get times 3/5. And then we can say the exact same thing. So we add this to choose 2. This is the case where the Mustangs win the tournament. So we have 3/5 squared times 2/5 squared times 2/5. And then if you factor this, you get 4 choose 2 times 3/5. Do I have, okay. Let's do this. Does that work? Yes, it does. Oops. Sorry. Oop. There we go. Okay. So we're factoring this out. So we have choose 4, 2, 3/5 squared times 2/5 squared times 3/5 plus 2/5. This is 1 right here. And this is equal to, apparently, 216 over 625. So if we put this all together, we have 3 times probability that x equals 3 plus 4 times probability that x equals 4 plus 5 times the probability that x equals 5. So this is our expected value of x. And if you do this all out, you get 4.0656. Any questions on that?
Yeah, I have a question.
Go ahead.
About when x equals 4 and when x equals 5, you do the Bernoulli trial and then you add or multiply another case like this. So you have 3/5. So in x equals 5, you have 3/5 to the 3/5 squared times 2/5 squared times 3/5. And what is that 3/5?
So this is the case where the Bisons win.
That's because the last game has to be the Bisons.
Yeah, because the Bisons won the tournament, or the Mustangs won the tournament. So this is the case where the Mustangs win the tournament.
So 4 choose 2 is how you organize the first 4 games?
Correct. Yeah, so I have the tournament here, right? And this one is going to be Bison or Mustang, but I'm not worried about that for the moment. We know that neither of them won in the first 4 games, so we know there's 2 Bisons that have to go into here and 2 Mustangs, right?
Yeah.
So, it's like, how many ways can I put the 2?
And then-
yeah.
Okay.
Yeah.
And it's the same for P of X equals 4.
Yeah, except
Is you do the first 3?
yeah. So we're not
Okay.
worried about this 4th one because we know someone's winning the tournament here. So we're just worried about, for example, two Bison wins and a Mustang win, right?
Yeah.
So how many ways can we choose that?
Okay. Thank you.
Yeah, apparently this was brutal because, yeah. Apparently this was a hard homework problem. This is on your homework, isn't it?
Yes, it is.
Okay, yeah. Okay. Yeah, this is a really long computation. Yeah, this one's easier. So what is the probability that when a pair of 6-sided die are rolled, either, meaning at least, one die shows a 5 or the sum of the dice is 8? Yeah, so Brendan's talking about a table that shows percentages. He's probably talking about a normal table in statistics. Which tells you the probability of being somewhere based on a standard deviation. So what do we need for this one? We need the number in the sample space. So what is the sample space? And we also need the number of the event. So real quick, what is the number of the sample space? So we have 2 dice, and they're 6-sided, and we're looking at the number of 36. So 6 times 6 equals 36, right? Okay, and then for calculating the number of the events, we need to say, okay, so the event equals E1 or E2. Have to be careful there. So nice. We're going to use the E1, E2 form. So if we're counting these, we can break these into separate events, but they are not disjoint. So let's let E1 equal at least 1 die shows a 5. I'll give you a second, like a minute to think about that. So we're calculating how many ways can we get 1 die showing a 5? At least 1 die. Yeah, so think about if we labeled our dice D1 and D2. Yeah, I'm seeing the right answer now. But so if we label the dice we should be able to say something. Right, so we have three cases, right? So we have the case where D1 equals 5 and D2 does not equal 5. The case where D2 does not equal 5 and D2, D1 is not equal to 5 and D2 is equal to 5. And then finally the case where both of them are 5. Yep. So if we have dice 1 equaling 5 and the other one not being 5, then there's 5 ways for that to happen because the other die D2 can be 1, 2, 3, 4, or 6. So that's 5 ways. Same argument for if D2 is 5. So we get 5 there. And then there's only one way for both of them to be 5. So we have 5 plus 5 plus 1 is 11. Do I have space after this? Yes. So that's, we calculated how big E1 is. E2. Oh, any questions on that before moving on to E2? Okay. So E2 is equal to, is the events where the sum of the dice equals to 8. So for this one, it's easier to list out the ways this can happen. Yeah. So I'll give you a minute to think about that. Yeah. Yeah, that's the correct formula. Okay, yeah, so I'm just going to write down a table So if the die D1 is 1, there's no way for the sum to be equal to 8 with 2. So this can't happen right here. 2 and 6 is possible. 3 and 5 is possible. 4 and 4 is possible. 5 and 3 is possible. And 6 and 2 is possible. So these are the events in E2. So the number in E2 is equal to 1, 2, 3, 4, 5. So remember, we're trying to find the number of E in E1, and this is going, or number in E. Okay. So the number in E is equal to the number in E1 plus the number in E2 minus the number in E1 and E2. So from this earlier slide, we found that E1 is 11. From E2, the number in E2 is 5, is shown here. And then we need to think about this intersection. So we see that this event right here, 3 and 5, and this event is also part of the at least 1, 5 event. So we need to subtract off those two. So finally, to get the probability of E, we get the number in E divided by the number in S. And if we remember from earlier, the number in S is 36.
Do we also need to minus off the 2 and the 6 since those are both the same as well?
No, those are different events because we're differentiating between the die.
Okay, so why is it that 3 and 5 can go out?
Because this one has a 5 in it and this one has a 5 in it, right? So it's part of, this is part of E1.
Okay, because yeah, E1 has a 5.
Yeah, so 3, 5, and 5, 3 are both elements of E1. So we have to subtract them off in the intersection. Good question. So 11 plus 5 is 16, minus 2 is 14. And that's equal to 7 over 18, which is a little over a third. So any questions on that? Yeah, so there are other ways you can calculate this, but this is the most straightforward. Okay. So for this one, we have a player pays $10 for the privilege to play a casino game. The player tosses a die 3 times with the following payoff: $10 for the first die that shows a 6, an additional 15 for the second die that shows a 6, and an additional 20 for the third die to show a 6. What is the expected amount of money the player will win by playing the game 1 time? So what we're finding is the expectation of X is equal to, so X equals the amount player makes. What are you doing? Player makes. So the expected value is 10 times the probability of 1 6 plus, so that's for 1 6, an additional 25, an additional 15. So that means they get $25, 10 plus 15 for 2 6s. And an additional 20 for the third die to show a 6. So they get 45 for 3 6s. Three 6s. So what's the probability of 1 6? So we have 3 dice, right? And we know one of them is a 6. The other ones aren't. Do we have to include the money spent? The money spent doesn't come into play until part B. So don't include the money spent. So does someone know what the probability of 1 6 is? Yeah, so 1 6 plus 1 6 plus 1 6 doesn't work. If you think about it, what would that say about the probability of 1 6 and 7 rolls? That would say you have 7 sixths. Yeah, so 1 minus 5 sixths to the third would be at least 1 6. And we're looking for exactly 1 6.
3 times 1 6 to the 1 plus, or times 5 6 to the 2.
Yeah. Okay, so why is it 3 here?
Because there's 3 ways. There's
Yeah.
3 ways that you can have 1 6.
Yeah, so it's 3 choose 2, right?
Yes.
Yeah.
I guess you're choosing where the 6 isn't.
Yeah.
You could do 3 choose 1, couldn't you?
Yeah, so 3 choose 1 is the same as 3 choose 2.
Yeah, but
okay, yeah. Depends on how you want to think about it. So the probability of 2 6s yeah. Yeah, so if you want to think about it, 3 choose 1 is where the 6 goes. 3 choose 2 is where the 6 doesn't go. Right, so choose n choose k is equal to n choose n minus k. Yeah, so we have 2 6s. So there's 2 ways to place those 6s. And then we know both of them are 6s. So we have 1 6 squared. And then the other one is not a 6, and there's a 5 6 chance of that happening. And that's equal to 15 over 216. This one is 75 over 216. Is it? Yeah. If you're curious what these are. Yeah. And then finally, the probability of 3 6s. And that one, this one's just an easy Bernoulli trial. So all three of them are 6s. There's 1 6 cubed ways for that to happen, and that's equal to 1 over 216. If we add these, so now we need to come and reapply our expected value. So we have expected value of x is equal to 10 times the probability of 1 6. Let me make sure. 6. 16, yeah. 75 over 216 plus 25 times the probability of 2 6s, and that was 15 over 216. Plus 45 times the probability of 3 6s. And so that's 45 times 1 over 216. And if you do the math out, you get 65 over $12. And that's approximately equal to $5.42. So I would not recommend playing this game. It costs way more to enter than you will ever win. Another way to look at this is you expect to lose. About $4.58, $4.58. Then so for B, we say, oh, so any questions on this whole big calculation?
I have a question.
Yeah.
Where did the 25 and 45 come from?
Okay, good question. Yeah, so I was calculating the expected value of x. So we get $10 for the first die that shows a 6, so that's 10 times the probability of 1 6. An additional 15, so that's 25, right? So we get 10 plus 15 for 2 6s, and then an additional $20 on top of that for 3 6s.
Okay,
So that,
thank you.
yep. Any other questions? The math on your quiz should not be as hard as this. Okay, so how much can you make? How much can the casino expect to make if 10,000 of these games are played each day? So 10,000 games, and it costs $10 to play. $10 to play. Yep, and so if they're playing 10,000 games, then they get, so they're, what is it, gross or net? One of them. Casino is paid, if I can spell correctly, 10,000 times $10 for each of these, for all of these games being played, and that's equal to $100,000. And then the casino pays out 10,000 times the expected value that they're giving to the players, so 5 times $5.42. That's equal to what? $54,200 about. So we have 100,000 minus 54, 200, and that's equal to 45,800 that they make a day on this game. Forgot the parentheses. Oh yeah. Yeah, so actually we could have just looked up here and, the player's expected loss is the casino's expected win, is what this is saying. So any questions on that? Is it net gain? Yeah, this is net. Because that's income minus outcome. So any questions? You good? Okay. Suppose a 3-person committee is formed for a club by drawing names out of a hat. If the club has 30 juniors and 20 seniors, what is the expected number of seniors on the committee? So the fact that we have expected number of seniors means that we're doing a probability problem. So let x equal number of seniors on committee. Committee is a nasty word to spell. So when you're thinking about the expected value, right, we always think about the value and the probabilities that go with it. So we can have technically 0 seniors, right, times the probability there's 0 seniors. And that's obviously 0. Plus 1 times the probability of 1 senior. Plus 2 times the probability of 2 seniors, plus 3 times the probability of 3 seniors. And since we're getting close to the end, we'll just start working on it. There is additional material in this discussion, and it will be Zoe and James will be going over it in our review session on Monday. So please either tune into the live session or you can watch that on YouTube. So the probability of 1 senior is, what time is that? I don't know. It's on Canvas. There might be an announcement, hopefully. So if we're thinking about this, this is sampling without replacement, and order doesn't matter. So we're just going to be doing choose. We're just going to be doing a choose operation here. So our entire sample space is going to be over all students. So there's 50 students, and we're choosing 3 out of them. So when we have 1 senior, we're choosing 1 from the seniors and choosing 2 from the 30 juniors. So we have that. So we have, let me rewrite this. So times choose 32. For 2 seniors, we're choosing 2 of the 20 seniors, so we have 20 choose 2, times Now we have only one junior that we're selecting, so 30, choose 1. All over, choose 53. And then the probability of 3 seniors is equal to choose 20 from 20 seniors, 3 to be on the committee. And then we select none of the juniors. So there's 30, choose 0 ways to do that. That's actually 1. And so that's the probability of each of these events. And these are gigantic numbers, and the answer apparently is 1.2. So what we do is we say, okay, we can take, so for the expected value, right, I can multiply this by 1, and then add this to multiply this multiplied by 2, then add that to this part multiplied by 3. And if you do that whole calculation, apparently you get 1.2. Yeah, I think the review sessions are at the same time. Oh, James is on. James, do you know when the review sessions are?
Yeah, they're during the office hour times we have on Monday.
Okay. There's the answer to that. 30 over 50 times 20 equals 1.2. I'm not sure why that would make sense. So any questions on this? I know I rushed it a little, but we are almost out of time. It's not, so Brent, so we have a question like, would 3 out of 50 times 20 work? I don't think so. I'm not sure why this, oh, okay, so I'd have to think about this. So any questions on all this or anything else in the discussion? Okay, so I probably, yeah, don't have enough time to get to this. So they will be going over some of these questions in the review session. So check that out. And also you can come to discussion sections and ask if you can't solve these on your own. Yeah. So thanks, everyone. I guess that's our time.